Hi, Science 8. So I'd like to go over that matter worksheet that you did last week. Before I get started, just make sure that you hand in the take-home exam. I think I got most of you have handed it in. I'm just missing a few. I'd like to have those marked fairly soon. Okay, so those of you who haven't handed that in, let's make sure we get that in. So I had you kind of take a little bit of a head start here and look at matter. So don't worry if you miss some of these, but I'd like you to fill in the correct answers if you have some that are incomplete or some that are incorrect. Okay, so just some definitions here. So what we define matter as is anything that has mass and volume, and mass is the amount of material that makes something up, and volume is the amount of space that it takes up. Okay, so mass you can think of as the sum total of all the particles within an object. Okay, when you add energy to matter, its temperature rises. So heat is a form of energy. Different changes of state as a result of energy changes. Okay, so you should be familiar with the six changes in state: melting, sublimation, evaporation, solidification. Another word for solidification would be freezing, condensation, and deposition. In terms of movement, particles in a solid are in a very, and we'll get to that in the next sheet here, but they're very tightly packed, so they can't move past one another, and at best they're able to vibrate. Liquid can slide past each other, and particles in a gas can move around quickly and freely. When you remove energy from particles, they move slower and the matter contracts. So what that contracts means is that the particles get closer together. That would be the opposite of expanding, where they get further apart. And the kinetic molecular theory basically explains the spacing and movement change. Kinetic basically means speed. So basically what the kinetic molecular theory is saying is, as you add in energy, particles move faster and they get further away from one another as you're going from the solid, liquid to gas states. And just a word on the contraction when things cool and the expansion when they heat up. This is why, like, for example, when you look at things like electrical power lines, why they're not held really tight. Instead, they have a little bit of give to them. So that means when it gets in the winter and they freeze and condense, they contract, they don't end up breaking. Okay, and then going to the summer, when they start expanding, they don't end up breaking. Right. So just having that extra cable is useful. Okay, next page here. So this is more having to do with the movement. So fixed basically means it's going to stay the same. Okay, liquid, the shape is not fixed, so it takes up the container. So think about, you're having a glass of water. What your water will look like is a glass that's put in. And then gas is mostly empty space. Volume is fixed for a solid and it's fixed for a liquid. So using the glass of water example, if you had 50 milliliters of water, it doesn't matter what the shape is going to be, it's still 50 milliliters of water. A gas will fit to the container. So gases are very easily expandable and they can be compressed. Okay, so that means they can, same thing as contract, so they can come in close together. Spaces between particles, again, the solid is packed together tightly. What we call that is basically a fixed lattice arrangement. So it kind of makes a pattern. Liquid is further apart, and then again, gas being mostly empty space, the particles are very far apart. Movement, again, solid can vibrate, liquids can slide past each other, and gases are free to move around quickly. Okay, so there's a very tight arrangement here. They can't go past each other. More space in the liquid, they can go past each other. Gases are basically all over the place. Most of it is empty, and they're moving around really fast and randomly. Okay, so there's no like kind of flight pattern to their movement. Okay, the changes of state. So sublimation is when you go directly from solid to gas. So think about something like dry ice would sublime. Um, Solid to liquid is melting. Uh, Liquid to gas is evaporation. Um, Condensation is gas to liquid. So like when you see like a bathroom mirror fogging up, that would be an example of condensation. Solidification is liquid to solid, and again, solidification is the same thing as freezing. And then gas to solid would be deposition. Now, in terms of the energy, again, heat is a form of energy. In terms of energy being added or released, as you're going from solid to liquid to gas, if you're going in that direction, you're going to need an addition of energy. And then if you're going in the opposite direction, you're going to need a release of energy. So when we say energy is released, the other way you can look at that, heat being released, is that the object is cooling. Okay, so because you're removing heat from the material. Okay, the next section here, and this is the topic I want to cover. A fluid is anything that can flow because it doesn't have a fixed shape. So most of you would be familiar with a fluid being a liquid, but also recognize that a gas is also considered a fluid because it's able to move. Okay, so those are the two types of fluids, liquids and gases, that are able to flow. So think about like hot air conditioner, right? So that's causing air to flow. Okay, density is what I want to look at today. That's defined as mass per volume. So the more dense an object is, the more it is, more mass you have in a given volume. The key to density is the spaces between the particles. When we use this word particles, we're talking about the small. You see pictorially we use little circles or balls to represent the particles, but what we actually are saying, the particles that make up objects, those are referred to as atoms or molecules. Okay, so if we had copper metal would be made up of copper atoms, and those would be the particles. If we had water would be made up of H2O molecules. Okay, so these are what we refer to as the particles. Typical rule of thumb is less dense is going to float on denser substances. Okay, so you think of anything that's floating. And as a rule, most substances are denser in their solid state. An exception would be water. And if you think about water and go back to the previous question, this is why ice floats because of that exception. Okay. So for the calculations, we're going to need to take the mass and divide it by the volume. We can determine the volume if it's given to us, or if we have to calculate it if it's regularly shaped. If it's irregularly shaped, then we'll use the displacement method, and I'll go into what these different methods are. This is a calculation that we're going to be doing, and your typical units, which are equivalent, okay, grams per milliliter or grams per centimeter cubed. One milliliter is equal to 1 centimeter cubed. Okay, so that's why either of those work. Okay, so I'd like you to add to your notes. We'll look at some density calculations here. Okay, so there's your formula, mass divided by volume. So let's go into some examples and I'll show you how to do the calculation. So here's kind of a basic one. You've got a 2 centimeter cubed. Okay, so that's cubic centimeters. So those of you who are taking Math 8, you probably did some volume calculations. So that's a way to express volume, centimeters cubed. Again, a milliliter is equal to centimeters cubed. Here's your mass. So simply use the equation, mass divided by volume, m divided by v, and then make sure that your final answer has units. Okay, so 3.18 grams divided by 2 centimeters cubed equals 1.59 grams per centimeter cubed. Now let's look at ones that are a little bit more difficult. Um, so here, this would be considered a regularly shaped object. Okay, so it has clear dimensions. So it's like this would be kind of like a box. And so suppose the mass of this box is 200 grams. We want to find the density. So now the the volume's not given to us, but we have to calculate the volume. Okay, so if you remember your shapes, um, volume is equal to length times width times height. Okay, so you find the volume that way, which is going to give you 100 centimeters cubed, and then the mass is given to you, and so you divide that and you get 2 grams per centimeter cubed. Okay, so again, this is a regularly shaped object, and we're using the volume formula of a rectangular prism. I think that's the way they refer to it in Math 8, and to get the volume. Okay, let's look at another one. Okay, so here's the so this would be an irregularly shaped object. It's got a mass of 10 grams. So what we're going to use here is called the displacement method to find the volume. So I can't use a ruler and measure dimensions as we did over here. So what we do is we have a container of water, and it's got a it doesn't really matter what the original volume is, so long as when we put this object in, it can submerge. Okay, so as long as this thing can completely submerge. So what you do is you measure you just set an initial volume of water. So you add water to this beaker. Okay, so let's say we add it to 15 milliliters. Now remember, if you don't remember what this thing is called, when you have fluid in a container, it makes that sort of that U shape. This is called the meniscus. Okay, so when you want to read from the meniscus, you want to read from the bottom of that little dip there. Okay, so you always want to be consistent with your measurement. So you take this irregularly shaped object, you put it into this container that already has a measured amount of water in. Doesn't matter if it's 15 mils or 20 mils, it's still going to work. So again, so long as this thing can completely submerge. So this is your before, and then after you put that in, what you want to look at is how much does it rise by. Okay, and so after you put it in, now the water level rises, and let's say it goes to 17.5 milliliters. So you started with 15 and it went up to 17.5. So you take your new volume with the object in minus the original volume without the object, and that gives you the overall volume of the object. So the object has a volume of 2.5 milliliters, and then you take the mass again and divide it by the volume that you just figured out, and then there's your density. Okay, so what I'm going to get you to do for today's class, it's a single worksheet just on density calculations. Another thing I should mention is density is a physical characteristic of a pure substance. So that means things like copper metal, lead metal, water, any compound or element, they have set densities. Okay, so again, it's a physical characteristic, just like melting point, boiling point is of different objects. Okay, so one of the things that we can do is if we have something, let's say it appears to be gold, one way you can see if it's actually gold is by determining the density. So if it doesn't match the actual density which is tabulated of gold, then it either A isn't gold or B is partially gold. Okay, there might be some impurities in there that cause its density to be different. Okay, so just the worksheet for today's class. Let me know if you're having any difficulty with it and need some help. Again, you should have that test on the waves unit handed in. Again, most of you have already done that, but if you haven't done so, make sure that gets handed in. Okay, and like I said, I'd like to mark that fairly soon. Again, look after yourself and just keep sending me any questions that you may have. Okay, take care. Bye now.